All right, we are moving on to 2.2, and we're combining it with 2.3 because they are very similar concepts, and it just doesn't seem like we need two videos. This is called scientific notation. So scientific notation is used to represent very large and very small numbers. Okay, so it's really, really big numbers like billions and trillions, and even we can use millions, and really, really small numbers like the size of a bacteria, super, super small numbers that are in the trillionths and things like that. Okay? So we're going to first start with writing really large quantities into scientific notation. So this is all large numbers. So it says when the number is greater than or equal to 10, we use a positive exponent. Okay, so if the bigger the number is big, we're going to use a positive exponent. Okay, so what we do, there's a little example, is we start at the very back of the number where the decimal would be. We would move the decimal so that the number becomes between 1 and 10. It can be 1, but it cannot be 10. Okay, and then we literally move the decimal, so you can see now it's 8.4, and then we times it by 10. It's always 10 to the 4th power because we moved it 4 times. Okay, so you can see we're still dealing with some exponents. So the decimal point moves 4 places to the left. So what we're going to do is practice moving this decimal and writing it in scientific notation. So this is 6,400. The decimal is always in the back of a whole number. We move it 1, 2, 3 times so that it ends up between 1 and 10. We're going to go 6.4 times 10, and I moved it 1, 2, 3 times, so I'm going to write times 3. So sometimes people think, oh, I just need to move it till all my zeros are gone. So they would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and move it one more and say 10. And they'd be like, oh, it's times 10 to the 10. But the number has to be between 1 and 10. So notice this number 57 is not between 1 and 10, so I have to move it one more time. That was 11 times. It was 3, 6, there's 3 there, 6, 9, change that to a 6, and then 2 more, 10 and 11. Now we have 5.7 times 10, and we moved it 11 times, so I put to the 11th power. Okay, the other reason you can realize, these are going to be positive exponents is if you think about our exponent rules, when we, took 5 to the 3rd power, it got big really fast, right? It went from 5 to 25 to 125. Same with like 11. It went from 11 to 121 to 1,331. So you can see those numbers get big really fast. So that's why these numbers are really big, right? Positive exponents, really big numbers. All right, so maybe pause here and see if you can do number 5. Do this one on your own and see if you can change scientific notation on your own, and then unpause and see how you did. All right, so 3, 6, 9, 10, 11, 12. You have to move it all the way to there, so you should have gotten 9.461, all of the digits, times 10 to the 12th, because we moved it 12 times. All right, down below, these are actually numbers that are already in scientific notation, and we are going to change them so that they're what's called standard notation, a standard number. And so instead of moving it from the back to the front, right, the right to the left, we're going to now move it all the way back to where it originally should have been. So they're going to end up looking like the numbers at the top. So the exponent, remember, is how many times we did move it. So now the exponent is how many times we're going to move it the other direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to do it again, but I'm going to rewrite my number kind of over here so you can see it a little better. So I'm going to go 7.034. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7, 0, 3, 4, and all of these blank spots become zeros. So 1, 2, 3, 4, 5, 6. And then I'm going to put my commas in, and there's our really, really big number. Okay, let's do this one. I'm going to rewrite it over here again, just so we have space. So 1, 2, 3, 4, 5, 2, 3, 6. Blanks get zeros, so 3 extra zeros, and put our commas in. Okay, maybe this is a pause time. You try this one, see how it goes, see if you can put it back into standard notation. So if I have my 5, the decimal is in the back. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 zeros. So without those little jumps, that's what it would look like. Notice I rewrite it without the decimal still sitting in the front. I can't write it with a decimal here and then have commas at the same time. So it needs to get rewritten without the decimal, please. All right, so writing really small numbers into scientific notation is 2.3. So the first slide we did, first page we did is 2.2, and then this is 2.3. And so this is changing really small numbers into scientific notation. So when the number is between 0 and 1, we use negative exponents. So think about that as well. When we did exponent properties, when they were negative, they went to the denominator and became these fractions, right? 1 over 6 to the 4th, right? 1 over 6 to the 3rd. And if I do 6 to the 3rd, that's 216. So it's 1 and 216ths, super tiny. So that's why it's negative exponents. Just like our negative exponents made our numbers drop most of the time to the denominator and made these really small fractions. So we do the same thing. We're going to still move our decimal. We're just going to move in the other direction. So if you look at the example, we move it 1, 2. We're still trying to get our number between 1 and 10. And our exponent is still going to represent how many times we moved it. It's just going to be negative. So I take my decimal. 1, 2, 3, 4. Again, we do not stop here because that is not between 1 and 10. That's still less than 1. So I have to go one more time. 5. Now I have 8.29, right? That's between 1 and 10. So I'm going to go 8.29 times 10. And then I moved it 5 times, so I'm going to go negative 5. And remember, it's always times 10. That's because our numbers are in base of 10. So big numbers we were timesing by 10, 10, 100, 1,000, so on. Really small numbers we divide by 10. Tenths, hundredths, thousandths, they're all just being divided by 10. So that's why we still times it by 10 every time. All right. 1 movement, 2 movement, 3, 4, 5, 6, 7. So we get 3 and 200ths times 10 to the negative 7. All right, here's one more that's standard to scientific. So pause, see if you can change it. Unpause and see if your answer matches mine. So you should have moved it 1, 2, 3, 4, 5, and 6. So 7 times 10 to the negative 6. You have to move it behind that 7 so that it's now between 1 and 10. If you leave it in front, that's less than 1 still. So we have to move it behind. So down below, 9, 10, and 11 are now scientific to standard. The same thing is going to happen as what we were doing on our scientific to standard on large numbers, except we move it the opposite direction. So, try to decide where I should write my number. I'm going to write it over here, and I'll show you why. So here's my decimal. Oops, it's a 5, not a 6. Let me fix that. So I have to move it 6 times. So I'm going to go 1, 2, 3, 4, 5, 6. Still ran out of room a little bit. And again, these are all going to be zeros. So I'm going to have, I like to put zeros in front of my decimals. You should practice that too. 1, 2, 3, 4, 5 zeros. And then I'm going to go 1, 0, 4, 5. So that's scientific to standard. All right, so again, I'm going to write it over here. I need to move it 5 times. 1, 2, 3, 4, 5. Add my zeros in. And then I'm going to put the 0 in front of the decimal, and I'm going to add 4 zeros. and then 9, 9. All right, pause. Try number 11. Okay, let's see how you did. So I take my 1, my decimal is here, I go 1, 2. So we should have just gotten that. And 100ths, and I know you're like, that's not a very small number, that's a penny. Do you consider a penny a really small amount of money? Yes. So, still a really small number. All right, so things to remember. So, large numbers equal positive exponent. And small numbers equals negative exponents. Okay, so here are your two independent practice problems. They're both in standard form, and you need to change them both to scientific. Okay, one's a small number, one's a large number. Okay, make sure they get done. Until next time.